Well, hello everyone, and welcome back. So now we're going to get into some fun stuff using functions in Excel, but we've also got some definitions on this page that are super important. So I'll go over the definitions as we answer this question. So we have Lucy sells in the East Division where the average sale is 30,000 and the average distance from the mean is 5,000. That's a sneaky way of saying standard deviation, because that is the definition of standard deviation. Her sales are 38,000. What is her percentile? So let's frame the problem. And the problem is we're looking for probability below x. And then we're going to pick the function. And this is going to seem a little overwhelming at first, but it will make sense by the time we get to the end of it. So we're trying to find probability, right? Because percentile is probability. So you look at the end of this. Oh, this is the one that ends up with probability. So it's got to be this one. But let me explain this a little bit. So what we're going to do is we're going to take x and subtract the mean, divide by the standard deviation. That's actually how you get a z-score. So that's going to give us a z-score. And then as you saw on the two tabs ago, you can use norm.s.dist with a z-score to produce a probability. So we're actually going to do all that. So let's talk about the case. We're going to call this one-tailed left. Now, strictly speaking, we're not just in the tail. We're literally everything to the left of where we're going to be. But we're introducing this terminology because you're going to see it down the road when we do hypothesis testing. All right, the mean or average given in the problem is 30,000. And the standard deviation is 5,000. That was also given in the problem. And so were her sales, the 38,000 for her sales. That was also given in the problem. And as you type all that, these graphs down here build automatically. You get two graphs. One has observed values and one has probabilities. And there's some overlap in information between the graphs. But the biggest difference between them is that the x-axis on this graph are the actual data values, whereas the x-axis on this graph are z-scores, effectively standardized values. And both are important. This one is going to end up being extremely important when we get to hypothesis testing. So now let's look at some of the terminology here. So tails. One-tailed left is what we use if the logic is less than. And percentile means less since it is everyone less than you. Kind of like when you took those standardized tests in like elementary school and they send it back to your home and they say you're in the 95th percentile or whatever it was. All right, one-tailed right is what you would select here if the logic says more than. So this said less than, or it said percentile. It said what's her percentile, which effectively means less than, everyone less than her. All right, probabilities. Norm.s.dist calculates the cumulative probability to the left. Norm.s.inverse calculates x when given the probability to the left. Most of the time we'll be using norm.s.dist. We'll be after the probability. And all probabilities under the curve add to 100%. Therefore, the probability to the right is 1 minus the probability to the left, which is actually a trick that you saw us do on the previous one when we were talking about the empirical rule. And we're trying to get the probability to the right, but we said, well, let's just take the little bit to the left and subtract it from 100%. Okay, so let's look at a few other things about these graphs. Both graphs show the z-scores. So here you've got the mean in the middle, and then this is one standard deviation, two standard deviations, three standard deviations this way, and so on here. Here it's exactly the same thing, right? The mean in the middle. But here we've standardized the mean so its value is 0 because this is a standard normal distribution as opposed to just a regular normal distribution. And then we're also being a little bit more explicit here about showing the vertical bars that separate out the standard deviations. Other thing to note here, and I really want to zoom in to show this to you because it's like super important, is that this one is filled with little dots. And so the whole idea here is that you should, when you see these curves and you think, well, what is that? What does that represent? It actually represents lots and lots of different observations. So if Lucy is here, then there's a lot of little dots to the left of Lucy, right, that she's better than. And then if you think about it, well, what does the height, like these little dots appear to be in columns. Well, what does the height of any particular column represent? It kind of represents the relative frequency of how many observations you would see at that X value. And as you can see here, there, as you're in the middle, the mean, there are going to be more observations at the X value in the mean than there will be out here in the tails. That's the nature of a normal distribution. Things tend to cluster around the mean. Most of the observations are around the mean, which is why we got those percentages that we got. And this turns out to be enormously important just because in point of fact, in the real world, most data is normally distributed, or at least close enough to be normally distributed that we can use normal distributions to analyze it. So that's really neat. All right, so here's your normal distribution. Here's your standard normal. The normal distribution, the x-axis measures distance in raw units, not standardized. It's symmetrical and bell-shaped. It's described by the mean and standard deviation. Those are the only two numbers you need to draw this curve. The mean is also equal to the median, which is also equal to the mode in a normal distribution. And the tails are asymptotic, kind of cool word, which means they never reach zero, since you could have an extreme outlier. So even though those look like they're hugging the x-axis, theoretically there's a little distance there that one of these little dots could hide in. Okay. The standard normal distribution is the same as the normal distribution plus. But wait, there's more. Plus the x-axis measures distance in standard deviations. So 1 standard deviation, 2, 3, also known as z-scores. And the z-scores measure distance from the mean. A z-score of 1 indicates 1 standard deviation above the mean. 2 is 2 standard deviations. -3 is -3 standard deviations below the mean. All right, so here we have Lucy. And as you can see, the calculation's already been done for us, both the probability and the z-score. That's really good for you to know because it gives you a way to check your work up here. But we actually want you to learn how to do those calculations. So let's calculate the z-score for Lucy. All right, it's going to be equal to, and now here we look at our strategy that we got here on the pick the function. So we take x, which is this number, minus mu, which is that number, and we're putting it in parentheses just like up here, and that's really important because if we don't, then the division won't come out right. And we're going to divide all that by the standard deviation. So basically it's the difference between my observation and the mean divided by the standard deviation. So basically it's that difference in standard deviations. Effectively we're normalizing it. All right, and so that's 1.6. So we're 1.6, Lucy is 1.6 standard deviations above the mean, which you can see here in the graph is really true. She's 1.6 standard deviations above the mean here. She's 1.6 standard deviations above the mean here as well. Now the question is, what percentage does that correspond to? So we know it's 1.6 standard deviations. You know, we could use a little empirical rule trick to kind of try to figure it out, but you know, when you're between numbers, it's hard. So you typically do it formulaically. And so we're going to use the norm.s.dist function off of this z-score with true, and there's the 94.5%, which is exactly what's on the graph. So what do z-scores measure? It's the average distance from the mean in standard deviations. And what is a standard deviation? It's the average distance from the mean. I'm going to ask this question a lot because we really want to make sure that you emerge knowing this. So Lucy's doing pretty good, right? She's better than 94.5%. So these are all, these little dots over here, all the green dots, these are all the people that she's better than. And the dots over here to the right, these are the people that are still better than Lucy. Okay, and that's it for this one. We'll see you in the next video.